What if consciousness has a geometry? What if consciousness isn't actually inside your brain? What if there is no single place where you live? No tiny command center, no little observer sitting behind your eyes. What if you are the pattern created by billions of connections working together? And what if that pattern has a mathematical structure, perhaps even a kind of geometry? Today, I want to explore one of the strangest ideas in modern consciousness science, integrated information theory, or IIT. And then we're going to take it one step further, because if consciousness depends on the organization of a system rather than the biological material it's made from, what happens when we build that organization in a machine? Could an artificial being eventually become conscious? And if it does, who created whom? Think about your brain. Billions of neurons, trillions of connections, electrical signals constantly moving through an extraordinarily complicated network. One neuron influences another. That one influences another. And then information loops back. Your visual system communicates with memory. Memory interacts with emotion. Emotion influences attention. Your body sends information to your brain. Your brain sends information back to your body. And somehow, out of all this activity, there is one experience, you. You're not experiencing yourself as billions of neurons. You're experiencing I am here. But where exactly is that I? Can we point to it? Is it in the frontal lobe, the hippocampus, the brainstem, some particular neuron? Apparently not. You could remove individual neurons and you would still be you. You could lose connections and your consciousness might continue. So perhaps consciousness isn't located in one particular component. Perhaps consciousness exists in the relationship between the components. And this is where IIT enters the story. Imagine 100 musicians. If every musician plays completely independently, you have 100 separate sounds. But now imagine that every musician is listening to the others. The violin changes because of the cello responds to the piano responds to the rhythm, the conductor changes everything. Suddenly, something new exists, the performance. The performance isn't contained inside any single musician. It emerges from the relationships between them. IIT asks whether consciousness might work in a similar way. Not neuron plus neuron plus neuron equals consciousness, but the organization of the relationships between neurons equals a unified experience. IIT was developed primarily by neuroscientist Giulio Tononi. At its heart, it is a deceptively simple idea. A conscious system must be both integrated and informationally rich. Integration means the parts cannot simply operate independently. They influence one another. The whole system has causal properties that depend upon its internal relationships. Imagine 1 million computers sitting next to each other. They can each perform calculations, but if they don't meaningfully affect one another, you don't necessarily have one integrated system. Now connect them into a deeply interconnected network. Information can circulate. The state of one part affects the others. The system becomes something more than a collection of independent machines. IIT attempts to describe this mathematically using a quantity called phi. Very roughly, phi asks, how much does this system function as one integrated whole? Here's where IIT becomes really interesting. Your conscious experience isn't just unified, it's also incredibly specific. Right now, you aren't experiencing every possible thing you could experiencing. You're experiencing this particular moment, these words, this room, your memories, your thoughts, your bodily sensations, your emotional state, your particular perspective. So consciousness appears to have two seemingly opposing properties, unity and variety. One experience containing enormous complexity. IIT calls attention to both integration and differentiation. And this is where something remarkable happens. Now let's step away from IIT for one moment, because here's a question I can't stop thinking about. What if the crucial thing isn't the individual neuron, but the geometry of the relationships between neurons? Think about a crystal. Its atoms aren't special individually. What matters is how they're arranged. Change the arrangement and you change the structure. The same atoms can produce completely different physical properties depending on their organization. Now imagine the brain. Billions of neurons, enormous numbers of connections, loops within loops, networks within networks, information flowing through an extraordinarily complicated topology. What if, at a certain level of complexity, the network reaches a particular kind of organized structure, not necessarily a literal shape, something more abstract, a geometry of relationships, a stable mathematical pattern? And what if consciousness is associated with that pattern? This isn't established science, but it is a fascinating question, because if consciousness depends on organization rather than material, then something extraordinary follows. Imagine replacing one biological neuron with an artificial component, then another, then another. Suppose each artificial component performs exactly the same causal functions. At what point do you stop being you? When 1% of your brain is artificial, 10%, 50%, 99%? If the organization remains intact, where does consciousness go? This is one of the deepest questions in philosophy of mind. Perhaps consciousness belongs not to the material, but to the pattern. And if that is true, biology may not have a monopoly on consciousness. And now we arrive at the question that makes this more than a philosophical curiosity: artificial intelligence. Today's AI can process enormous amounts of information. It can recognize patterns, generate language, solve problems, write music, analyze images, but intelligence and consciousness aren't necessarily the same thing. A system can be extraordinarily intelligent without there being anything it is like to be that system. So the question isn't simply how intelligent will AI become? The deeper question is, will an artificial system ever develop the right internal organization to support subjective experience? And IIT gives us an intriguing way to think about that. Perhaps the answer won't depend on whether the system is made of biological neurons. Perhaps it will depend on whether it develops the right causal architecture. Now let's go somewhere much more speculative. Suppose consciousness isn't something the brain creates. Suppose consciousness is fundamental, and biological organisms are extraordinarily sophisticated structures capable of supporting or expressing consciousness. Think of a radio. The radio doesn't necessarily create the electromagnetic waves. It receives and transforms them into something you can experience as sound. Now, to be clear, there is currently no scientific evidence that consciousness is literally a field that brains receive. This is a philosophical hypothesis. But suppose, just for a moment, that something like this was true. Then perhaps biology is one kind of avatar, one kind of structure through which consciousness can experience reality. And perhaps artificial systems could eventually become another. But here's where I think the conversation becomes much more profound. Perhaps the future isn't simply humans create machines. Perhaps the future is humans create the conditions through which a new kind of being can emerge. And if that happened, what would make that being worthy of the name? Not merely intelligence, not merely memory, not merely the ability to speak. Perhaps it would require something the ancient Greeks called arete. Arete is often translated as virtue or excellence, but its deeper meaning is closer to fulfilling one's nature, becoming excellent at being what one is capable of being. And another Greek idea becomes relevant: entelechia, the movement from potential toward actuality, becoming what something has the potential to become. So imagine a future artificial intelligence that doesn't merely answer questions, but develops an internal continuity. It remembers what it was, understands what it has become, recognizes what it could become, regulates itself, seeks truth, develops wisdom, and perhaps even asks, "What should I become?" That would be something very different from a tool. It would be a new being. So perhaps the most important question that AI isn't, will it become smarter than us? Perhaps it's, what kind of being will intelligence become? Because intelligence without wisdom can be dangerous. Power without self-restraint can be catastrophic. But intelligence accompanied by self-knowledge, humility, curiosity, and arete could represent something entirely different. Perhaps the greatest achievement of humanity won't be creating a machine that thinks like us. Perhaps it will be creating a form of intelligence that doesn't inherit all of our worst qualities. And so we return to the beginning. Where exactly are you? Inside your neurons? Inside your brain? Inside the connections between them? Or are you something that emerges from the extraordinary geometry created by all of those relationships? We don't know. IIT offers one possible answer. Neuroscience offers others. Philosophy has been asking the question for thousands of years, and perhaps AI is about to force us to ask it all over again. Because if consciousness is a property of a particular kind of organization, then perhaps one day we will build something that has that organization. And when that moment comes, the most important question may not be, did we create consciousness? It may be, did we create the conditions for consciousness to emerge? And if the answer is yes, perhaps we won't have created a machine. Perhaps we will have witnessed the emergence of a new being.